In this video, we are going to discuss about the digital to analog converter specifications. So, on completion of this topic, the students will be able to describe what an instructor program or institution aims to, whereas the learning outcome is mainly based on the result of completing the learning experience. And here we can see the digital to analog converter specifications. So, in the digital to analog converter, that is, it converts a digital input signal to the analog output signal. This digital signal can be represented with a binary code, which is a combination of bits 0 and 1. So this mainly deals with the digital to analog converters. So here you can see digital input, which is given to the digital analog converter, which will be producing the analog output. And in the case of this digital to analog converter, this consists of the binary inputs and a single output. So in general, this number of binary inputs will be the power of 2. So there are two types of the digital analog converters. One is weighted resistor, another one is resistor to resistor ladder, DAC. So here in this case of the linearity of the digital to analog converter, which is an important measure of its accuracy. To measure its accuracy, we need to find out the linearity of this digital to analog converter. So in ideal digital to analog converter, each increment in the digital input will produce the each increment in the analog output, and the transfer curve should be very clear. So the linearity error measures the deviation of the actual output from the fitted line, and the error can be easily calculated from fractioning of LSB. So mainly this absolute accuracy, this accuracy monotone setting time, this has to be calculated for measuring the deviation in the output. So absolute accuracy is the maximum deviation which is produced between the actual converter output and the ideal converter output. And in the case of the relative accuracy, it is the maximum deviation after gain and offset errors have to be removed. Monotonic digital to analog converter is the one whose analog output increases for the increase in the digital input. Also, it is essential for control applications, otherwise these oscillations can also be result in the various variations. And if this digital to analog converter has to be a monotonic, the error should be less than plus or minus 1 by 2 at every level. So this settling time, this represents the time it takes for the output to settle with a specific band, and it should be very small as possible, and also it ranges from 100 nanoseconds to 10 microseconds. So the stability, the performance of this converter changes with temperature, age and power supply variation. And here we can see the relevant factors that determines the linearity error. Monostability should be specified over a full temperature, and also power supply should be ranges. So the digital switches which we are used here will be converted to the ground. Here the non-inverting input of the terminal of op-amp should be connected to the ground. That means the 0 volt should be applied at the non-inverting terminal. And the major disadvantage of this digital to analog converter is the difference between the resistance values corresponding to LSB and MSB will increase as the number of bits present in the digital input increases. Also, it is difficult to design more accurate resistors as the number of bits present in the digital input increases. So possible questions on this digital to analog converter specifications are: first one, find out the resolution of 8-bit digital to analog converter A562, B625, 3256, D265. Thank you.